Hello, welcome everyone. My name is Fabio and I'm part of the DEX team. And today I'm going to be presenting on one of our major initiatives that we're working on right now, which is called DEX Mesh, a peer-to-peer network for sharing DEX orders. And now I'm going to learn how to use the clicker. Nice. So just a quick overview of this presentation. Just want to go into some background on DEX, the protocol, kind of explain what caused us to build Mesh and why we need it. Then go into what exactly Mesh is and how it works. Some potential use cases, the tech stack that we're building on top of, and then one feature that we're very, very excited about, which is full browser support for our peer-to-peer network. So DEX is a protocol for exchange. We've been around since 2017. And what we mean by protocol is that any exchange that wants to build on DEX, they just need to have the orders in their order book conform to the DEX standard order format. If they do that, then they can use the same set of smart contracts to fill their orders. And these smart contracts are audited and used by many projects, so they don't have to reinvent the wheel. And it also means that they can use a bunch of developer tools that we've built to interact with our smart contracts, to UI kits that they can use to build their DEX front end, all the way to Mesh. So we've had quite a bit of value transacted through DEX so far, and a number of projects that have built on top of us. So unlike other decentralized exchanges out there, we're not an automated market maker. Think Uniswap, Bancor, and we're also not a fully on-chain exchange. Think Oasis DEX or ETH to DAI. Instead, we do something called off-chain relay and on-chain settlement. So that means orders live off-chain. They can be hosted and shared in any way. And then they're only actually pulled on-chain once you want to settle them. So if you want to fill an order, you would submit it to the Ethereum blockchain. And what this kind of structure lets us do is have a much more efficient market, because it's very cheap to create new orders and update orders. And also have this kind of order book style market, which is the way most markets in the world function. You have a bunch of orders of people who want to buy and people who want to sell. And our bet internally is that this order book style market will continue to offer better prices and even outcompete automated market makers because two fundamental reasons. One is they don't rely on arbitrage in order to adjust the price to the overall market. And they also can sustain very, very large buys and sells without programmatically moving the price drastically, so lower slippage. Okay, so we have all these orders, and they're all living off of the blockchain. Where are they stored? Today, most of them are hosted by relayers. And relayers is literally any entity that stores a database of DEX orders and helps buyers and sellers find each other. And because all of these relayers are built on top of DEX, all their orders are exactly the same in terms of their format. So theoretically, you could take an order from LedgerDEX and you could fill it on Open Relay. And so this is really cool because it means we can create a shared pool of liquidity that is actually being used by all of the relayers. And now they can all have more orders on their books, better prices, and thicker order books. But the problem is, how do those relayers share this liquidity? Now, the kind of silly approach is say, well, why doesn't every relayer just connect to every other relayer's API and pull their orders? So, end-to-end connections. But the problem there is, what if a new relayer pops up? Now all of the teams need to get their engineers out and be like, all right, guys, we got to integrate one more API. Let's do it. And so it's very, very engineering intensive, and it's a huge barrier to sharing this liquidity. And this is actually one of the big reasons for why we decided to build Mesh. We wanted to make a peer-to-peer network that makes it very, very easy to share DEX orders. So DEX Mesh is a gossip-style peer-to-peer network. Anyone in the world can spin up a node, and they will immediately get a stream of orders of all of the orders that are available on all of the relayers. And from these orders, they can fill them, they can use them to use with a DeFi protocol, et cetera. And if they want to share orders, they just post an order to their mesh node, and it just automatically shares that order with all the other mesh nodes. And so what are some of the benefits of mesh? The first is that it's completely decentralized off-chain order propagation. We have a lot of projects that have come to us that don't want to compromise on decentralization, and we don't want them to either. So now they can use ZeroX without having to connect to one specific relayer. Instead, they can just connect to mesh and connect to all the relayers. The second one is this concept of shared liquidity. It's a very weird concept because in centralized exchanges, every exchange is trying to monopolize their liquidity and put a moat around it and charge access to it. But actually, it makes a lot of sense. If you are the relayer where an order was originated, once it gets filled, even if it's on another relayer, you'll receive a fee for it. Similarly, if you spin up a UI that's pulling liquidity from mesh, you can also tack on a fee for providing this user experience to the peer-to-peer network. And the third one is market formation. When you're creating a new asset or you're creating a new economic system, one of the first questions your early adopters are going to ask is, where can we trade it? Where can we buy it? And usually the answer is, well, we got to pay a listing fee to Binance, and then maybe we can all trade it there. But now there's an alternative. And instead, you can instruct your followers or your early adopters to spin up a mesh node and trade with one another over a neutral, permissionless network. OK, so let's go through some use cases. Let's say you want to build a DEX. One of the hardest things to do when you're building a DEX is to bootstrap this two-sided marketplace. You have this classic chicken and the egg problem where user comes to your site and there are no orders. So instead of that, what you can do is you can connect to the mesh network, and for the asset pairs that you care about, you can start pulling in orders so that when the first user comes to your site, bam, there's already a ton of liquidity that they can pick from. The chances of them sticking around are that much higher if there's already liquidity for them to access. What if you're creating a new asset? Well, instead of going to Binance, why don't you list yourself? And the idea here is using our open source UI kit as well as mesh, you can now start selling your tokens to your early adopters and let them sell it to one another through a peer-to-peer network. This is actually a screenshot from a project called Verisafe, and that's exactly what they did. What if you're a market maker? Now, instead of having to pick one relayer where you have to decide to post your orders to, you can send your orders into mesh and immediately have them show up on all the relayers. And what's really cool about this is when a new relayer comes online or when a new DeFi protocol comes online, you don't need to know about it or do anything about it for them to get access to your liquidity. Another really interesting aspect of mesh is, we're used to this world where there's an exchange which defines the market mechanics for their particular platform. And as a market maker, if you want to trade with traders, you have to follow a bunch of rules, and you can't really innovate when it comes to market mechanics. With mesh, market makers can also connect directly to traders. And this actually we are seeing is kind of opening a bunch of new possibilities for how market makers can compete with one another. We are seeing market makers that want to create request for quote systems where they'll say, well, we want to give different counterparties different prices depending on whether we think they have alpha. And now we can do that where we can offer kind of a generic price and then have this back and forth with the trader. Another example is a market maker that wants to price match Binance. So, hey, we'll give you the price that's on Binance at the point where we execute this transaction. And all of these kind of new ways for them to compete and offer better prices are being unlocked through mesh. What if you just want to trade the new, coolest experimental asset that hasn't been listed anywhere because there's 100 people in the world who know about it? this is going to feed into the browser support, which I'll talk about a bit more later. But let's say you're a project called StableCat, and you created a new CryptoKitties-backed stablecoin. What you can do is you can send your followers a link to an IPFS site, and when they click on that link, it will show them an open source DEX UI, and it will run a mesh node in the browser that will directly connect their browser to all the other early adopters of that project. And so this is going back to that market formation piece, where we think that a lot of markets are going to start off on mesh, and then once they become popular enough and big enough, then they're going to start getting listed on relayers and on centralized exchanges, et cetera. So what is mesh built with? It's written in Golang. It compiles down to WASM, which lets it run in the browser. We're using libp2p, their Go implementation of GossipSub, Kademlia, DHT, AutoNat, and PeerStore. I forgot to mention PeerStore. LevelDB is what we use for our persistence layer, and we use Go Ethereum for interacting with the Ethereum blockchain. So now I want to dive a little bit deeper into browser support. How do we actually get this thing to run in the browser, and what are some of the challenges that we faced? So obviously compiling down to WASM lets our code run in the browser. Luckily, libp2p also compiles to WASM. For the persistence layer, though, we had to figure out a solution that could work in both browser and non-browser environments. So what we settled on is to use LevelDB in both environments, but in the browser, we would shim the file system with BrowserFS, and under the hood, we can use local storage or IndexedDB. This is great because we don't have to have two different persistence solutions. On the libp2p side, PeerStore can be configured to use LevelDB. PeerStore is a persistent module. And then the most important piece is actually supporting multiple transports, and transports that can enable different kind of connections. So we can use TCP when we're connecting a non-browser to a non-browser peer, WebSockets when we're connecting browser to non-browser, and ideally Webrtc to do browser to browser connections. And the reason why I say ideally is because the libp2p package Webrtc Direct currently only works for browser to non-browser connections. And the reason for that is because browsers are not dialable. You can't open a socket in your browser. And so they need some other mechanism to bootstrap that Webrtc connection. Maybe just a little bit of background. Webrtc is a fairly new protocol that was developed by Google. And it's mostly used for real-time communication, video and audio. If you've used Google Hangouts, Skype, et cetera, they pretty much all use it. But in their use case, they always had a centralized server where they can bootstrap the initial connection. Here we don't. And so we're working together with Protocol Labs to develop a specification on how you can bootstrap a Webrtc connection over a third peer. So you imagine another peer in the network says, I'll help you connect to each other. But once it's established, that connection is a direct connection from one browser to another. We're getting very close to MVP support for browser support, and are hoping to get that out by the end of the month. Cool. So if you want to learn more about Mesh, here's our GitHub, our documentation link, and Discord, where you can find us, and you can always talk to us. If you have any questions, I'm happy to answer any of them. Thank you so much. Yeah.
Right. Thank you. It's already working on some testnet, maybe on Rickby or Ropsten.
It's already on mainnet.
Mainnet.
It's already on mainnet, and the reason for that is, it's not really security critical in the sense that it's just sharing this off-chain data. And so you can share that for orders that are made for mainnet or for Rinkeby. So we actually have support for 3 testnets and mainnet. But it's still a beta. And where that comes in is there's still a lot more that we want to do in terms of security to make it much more robust. I guess I kind of forgot to talk a little bit about that. But There's a whole bunch of attack vectors that can be used against peer-to-peer networks. There's resource exhaustion attacks, there's DDoS attacks, there's Eclipse attacks, the list goes on. And luckily, we're building on Liquidity, and they have a lot of things already in place. But there's certain things that are specific to our use case where we need to add additional security mechanisms. So I guess one example is the resource exhaustion attack. So here is, a peer-to-peer network has a certain amount of bandwidth, certain amount of storage capacity. So how do you decide which orders to store? And the way that we're solving that is by actually tying the resources available in the peer-to-peer network with the scarce assets that are listed on the Ethereum blockchain. And making it such that you must own a certain amount of a token on the blockchain in order to be able to post more orders on the network.
Okay. One more question?
Yeah.
I was just curious about how you handle regulation, because if you have users that are spinning up peer-to-peer trading facilities, basically, I can imagine BaFin coming down like a ton of bricks on somebody.
Yeah, that's a good question. So I think the important thing to realize is that trading is not illegal. Exchanging things is not illegal. What is illegal is trading securities in an unregistered offering. I'm not a lawyer, but and so the technology that we're building can be used to trade digital assets in a VR game, or a sword for golden coins. Yes, it obviously can also be used for other things potentially, but really what we're building is just the fundamental infrastructure. And so I think the regulation is probably going to come on the parties that want to have a relationship with end customers and facilitate the exchange of, let's say, securities.
So if I understood correctly, the makers and takers are off-chain, and then we make some kind of atomic swaps on-chain.
So it's just a settlement. Yeah, exactly. You can call it an atomic swap. Yeah, it's an atomic exchange of two assets.
So is the market custodial? And if it's not, how do we make it friendly for the users?
So it's non-custodial. It's a non-custodial in the sense that every user has a private key. With that private key, they can move those funds at any point in time. Right now, we're using the ERC20 allowance mechanism in order to allow the protocol to move funds on behalf of users. And so, that piece does involve some trust in the smart contracts that we've written, but they're obviously minimized, and you can read it. Exactly what it's going to do with your funds once you give that permission. We would love to move towards a model where we don't have to do that, and we don't have to even have users provide that allowance. And it is something that might be possible with meta transactions in the future, where the user can actually submit the permission to move those funds when they're sending in the transaction. Cool. Thank you very much.